Hello everyone. Today is July 25th. In this video, I am going to show you the next features which I have added to my Razorpay clone project. So first I will if you are able to recall, in my last project video I have shown you the fixed window rate limiting. So in the today's video I am going to show you the sliding window along with the token bucket. Also I'm going to show you the idempotency and the caching. Okay, so let's get started. First we will see the sliding window and the token bucket. Okay, so for the sliding window rate limiting, we know that we have a window and that window slides, and after it slides the request which are means behind that starting point are discarded. So what we have done over here, we have actually took the current time which is stored in the now, then the floor ms means we have found the millisecond where the request was actually started. We took the now minus the window seconds, how much for time for the window last, took the window second, then subtracted, we got the floor, means now we have the range from the floor till the now. That much is the range for our sliding window. Then we took the radius key over here. Then over here we have took the z set. Z set is actually a sorted set. We took the z set in which the request will be put down. Then over here I removed the request based on their score. Okay, so the range was from negative infinity to that floor. So whichever request lie from the negative infinity and behind that floor, also that on that floor point, are then removed. Okay, on the basis of their score. Then took the count how many requests are present in that particular window with the help of z card. Then if the count is not null, took that count, otherwise we could start from the zero. If redis fails, we still want to allow that request, so we are starting from the zero. But if the current is greater than max request, means the if it is greater than the request allowed, then what we are doing, we are actually finding the oldest request. As it is sorted, then we are finding the oldest request over here, means we will pick the first oldest request. And we have also added the retry, means fallback. If it fails, then we could retry after 1 second over here. Then if it's not empty and null, then what we are doing, we are getting its score. Okay, score means its value. Okay, and if it's not null, then what we are doing, we are creating an window and removing it. And we are also giving it how much after how much time it should restart. So that's the logic which we have wrote over here. And then denying its result. But what happens if the means if the request over here, as you are able to see, if it's in that particular range, means it's less than the maximum request allowed, then what will happen, we will actually add the current request in our set and we will expire it. Okay, we will expire this request and then allow it. Over here, if you want to means if you want to understand it with the help of example, I have took an example for which the window size is 4, the maximum request allowed is also 4. Then initially, as the count was 0, this request came in. After this, consider that till this much the request came. Okay, now we want to figure out that does it is in the window size. So what we did, we took the 1004 and subtracted 1001. So we got 3 second. So the window is of 4 second. We got 3 second, means we do not have problem with this request. And the request are also, the count of request is also 3, which is less than the maximum request, so there's no need. Okay, then the next thing, when the next request came, which came at the 1007 millisecond, So the now at that point was this much. Then we calculated the floor by subtracting the window seconds from it. We got 1003. So in this case, what will happen? The request considering the at the 1003 millisecond and before that which request came will be then removed. So that's what this much request will be removed from it. So this is the logic of the sliding window, how it works. Then over here there's an issue that if multiple concurrent users came at the same time, okay, so they will have different threads and they will access the code. What will happen? They will not be able to figure out the difference, means they will all have access to it. So that's why it's not thread safe. So what we have done, we have used the Lua scripts that runs on the Redis server. So for which we have over here created a sliding window Lua limiter. Okay, as you are able to see, this is the code for the sliding window Lua. As per that, we are actually passing our details, okay, for the sliding window. That's the same logic which we have used over there, just we have added the Lua script to it. Then for the token bucketer as well, multiple concurrent threads could access it. So for it as well, what we have done, we have used the Lua script. Okay, as you are able to see, we have over here used the Lua script. Then this was about the rate limiting. Rate limiting is actually really important for your interview as per the means uh, questions are asked on the system design, and in system design rate limiting is an really important concept. So this concept could be asked in the interviews as well. So for the interview point of view, it is really important. Okay, then we saw the sliding window along with the. Okay, now we will see the idempotency key. Actually, what does idempotency means? If a user is trying to update certain things, but he is getting the response again and again, means he is creating again and again. So that's not possible. What we want, no matter what, whenever you try to perform, okay, same operation, if you are performing the same operation, it should only update once. If it fails due to a server issue or timeout, whatever be the cause, but it should only update single request only once. So that's what the idempotency key means. It is also a really important concept. It is actually asked in the interview. So it also comes under the topic system design. Then what we actually do to solve this problem, we create an idempotency key and pass it in the headers, and along with it we store it. Okay, so we will see the code for it. First I have created an idempotency store over here, which is an interface which actually have these methods. It is as similar to the Redis. So we have created a set if absent store to store it, the idempotency key, get the idempotency key and delete it. Then created a Redis Redis idempotency store, which actually has the logic for that methods which I have shown you. We have created the prefix over here. Then we are writing that if absent, set its status to in progress and return true, else return false. Means if the idempotency key is absent, then what we will do, we will set that key to in progress and then return true. Okay, for storing purpose, we are actually setting its prefix key and then storing it. For getting, we are getting it. Okay, then the next thing is to delete, we are deleting it. Then comes the idempotency filter. So as we have created the filter, and in the security web config we have added the filter after. What we want, we want the access to the merchant context. So we need to add the filter after the API key over here, API key authentication filter. And for the JWT also, we want to add it after the JWT authentication filter, which we have added over here. Then about speaking about the idempotency filter, what we have done over here, we have first took certain methods, as we want to only restrict the put, patch and delete. Put, post, actually yeah, over here it should be patch. Okay, for this request we want to restrict it, so we are checking whether this means the request are from this. If not, then we are passing to the filter chain. We took the header from the idempotency key which we are going to pass. We took the key. If it's null or blank, then we pass on the chain. Okay, and we have added it to the JWT and API key. From there, as we have added it, after that we are getting the access to the merchant context, from which we are getting the merchant ID. If it's null, we return the merchant ID. Over here what happens, issue is that if a merchant has, if two merchants has the same raw key, then we will not be able to differentiate between them. So we are accessing the merchant ID and then combining it with the raw key. Okay, if it's not null, we are combining merchant ID with the raw key and then passing on it as a key. Then we check whether the key which we have passed is in the progress TTL. Progress TTL, which here we have defined its duration to 30 seconds. We check whether it's in progress TTL for thread safety. Okay, if it's not, means if it's absent, we will mark it as true. We will get it in the claim. What will happen here also, we have the issue with the thread safety. If 1000 request came, then the first request which we have took, it will be marked true and then pass on, but the other request will be marked false. Okay, so that's what that's why we require the set if absent function over here. If it's not claimed, okay, means if someone is already having the access to the thread, then what we will do, we will get the thread which is there in the Redis server. If present and the idempotency store is not in progress, then actually we will return the value from the Redis. We will look at this replay function later on. But if not, we actually throw an exception. Then we are actually getting the caching. Means caching means content caching response wrapper is actually helpful if you want to update certain things in the response, or get few things from the response before passing on to the MVC server, MVC layer. So that's what we have done over here. We have passed the response, created an wrapper of it, then pass the wrapper. If there's an means exception occurs, we are passing it over here, but if not, we are getting the details from it. Okay, and then storing it over here. We are also deleting it if an error occurs. Then over here comes the replay method. Replay method does one thing, that it provides us the idempotency key from the Redis server. As we have added the separator over here, we are getting the if it's less than 0, we are getting it, but we are actually getting the status as well, as well as the body, and then setting the status, content type, character encoding, and output. Okay, so this is the code for the idempotency filter. Some part could be configured as per our business logic, but I will show you by running it. If you go over here in the login, when I hit the login request, wait a second, there is an issue over here, I think so. Okay, it's running. It has not ran until now. Okay, this application has ran successfully. When I hit login, I got the access token. Now we have logged in. Now I will generate the API key. generated the API key. Now I will create the order. But before creating an order, in the headers, I have passed the idempotency key. Over here, I will do the order as 9 right now. Okay. So this is the orders. I am creating it and pass the order ID. In the body also, I need to pass 9 over here. Now I will hit the request. The order is created, and if you see in the headers over here, attempt left is 1. Okay, as we have added the rate limiting, our rate limiting is also working fine. Then I will hit it again. Okay, now the remaining attempts are 0, and in the body also we got it. So the idempotency key which we have added is working fine. Then if we go over here and get the keys, so the keys are also being added over here. See, this was the key which is been added to our redis. Okay, so the redis is also working fine. After that, we need to understand few things. That is the means there are two issue in the caching. The first is the stampede. Second, cache penetration. Cache stampede means what happens when a popular key value is actually removed from the cache. Okay, and then consider that 1 million requests are coming to get that get that popular key value, but it's removed from the caching. That what will happen, that request will go to the DB, but there will be load on that DB. So how this problem could be solved? This problem could be solved by two methods. First is we could define the logic TTL. For example, we define it 30 seconds, and real TTL which we define as 60 seconds. Then after the logical TTL is expired, from that 30 seconds to 60 seconds, when it's there, we will actually we'll update the cache over there. In that case, the second case is if the TTL is 60 seconds and when the 52-second is going on, what we could do, we could actually uh, the 10% request which are coming, that could be cache miss. If it's cache miss, what will happen, it will go to the DB and fetch it and put it into the cache, but the 90% request will be cache hit. So that's how the load could be handled. Then the second, which I talked about, the cache penetration, it is an attack where a actor tries to provide wrong key, and we will go and found if it's not found in the cache, we will look into DB. Okay, so that's an error, so it could be solved with the help of Bloom filter as well. Okay, we will means hash all the API keys, and then we will check on it. So these two problems, and I have told the solution from for them as well. So this was the caching part which I was talking about. In the next video, I am going to actually add the Kafka. So stay tuned for that video. Thank you.